All right, in this lesson we are going to be looking at powers of a power. So it's basically exponents that are being raised to the third power, or raised to a power, okay? So in this case I'm taking x squared, which I'm raising to the third power. So just so you can see what's happening, x squared raised to the third power really means x squared times x squared times x squared. And of course, if you remember, when you multiply exponents, or when you multiply monomials, you really add the exponents. So if you need to take this a step further, x squared is really x times x times x times x. I should maybe fix this here. Times x times x. So together, I have 1, 2, 3, 4, 5, 6 x's, x to the sixth power. Hopefully you can figure out that the shortcut to that would be to take x to the 2 times 3 and get x to the sixth power. Okay? Notice here you only have one base. It is different than these ones we've done previous days where it looks like this. Here you have two bases, so you add the exponents. But when it is like this, you only have one base, and then you multiply the exponents. All right, here, be really careful because it's the quantity 2x squared to the fourth power. Many people remember to figure this out. What this really is, again, is x squared times x squared times x squared times x squared, 4 times. If you add the exponents, 2 plus 2 plus 2 plus 2 becomes x to the 8th power. Of course, the shortcut would be x to the 2 times 4, which is x to the 8th power. Many people forget that they have to take 2 to the 4th power as well. So I do need to take here 2 to the 4th power, and 2 to the 4th power is 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So my final answer here should be 16x to the 8th. All right, so here I'll kind of try to write these out a little bit shorter now. This is really 3 squared, and then x to the negative 3 times 2, because I only see one base and I'm raising it to a power out here, and y to the 5 times 2. So 3 squared is 9, x to the negative 3 times 2 is negative 6, y to the 5 times 2 is 10. You may not leave negative exponents in your answer. So if you have negative exponents, they do need to go to the opposite place. Remember to use reciprocals. So right now, this x that's right here is not very happy. It's being negative, and it needs to be moved down to the basement so it can become positive. Okay? The 9 does not have a negative exponent on it, so leave it. The y to the 10th does not have a negative exponent on it, so leave it. But that x to the 6th needs to go to the basement so that it can become positive again. All right, on this one, very similar. I have negative 4. Be careful, because I do need to have that negative in parentheses when I am taking it to an exponent. So it is negative 4 squared, x to the 2 times 2, y to the, there's a little 1 right there, 1 times 2. So negative 4 squared is negative 4 times negative 4, which is positive 16. X to the 2 times 2, which is 4. Y to the 1 times 2, which is 2. And that's how that one should look. Similarly, negative 4 to the third power. X to the 2 times 3, y to the 1 times 3. Negative 4 to the third power, make sure if you're going to use your calculator that whenever you are raising a negative number to a power that you put it in parentheses. Negative 4 to the third power is negative 4 times negative 4, which is positive 16, times negative 4, which is negative 64. X to the 2 times 3 is 6, y to the 1 times 3 is 3. And that's what that one would look like. All right, here now we're getting a little more complicated. Now I want to raise something to a power twice, and you can do this a couple of different ways. You can do these two first and then worry about the inside. My guess is that most of you won't do that because you want to follow the PEMDAS rules, which tells you have to do inside the parentheses first and then work your way out. So if we take what's inside first, I will have 6 to the second power, x to the 3 times 2, and y to the 4 times 2. All of that is still raised to the third power. Okay, so I will have 6 squared, which is 36. X to the 3 times 2 is 6. Y to the 4 times 2 is 8. Raised to the third power. And then, now that you've simplified everything inside, you can kind of do that again. So now I will have 36 to the third power, x to the 6 times 3, since I'm raising to a power and I only have one base, 8 to the 8 times 3. Again, I only have one base and I'm raising it to a power. So I need to figure out what 36 to the third power is, which is 36 times 36 times 36. That's 46,656. X to the 6 times 3 is 18. Y to the 8 times 3, which is 24. And that should be your grand final answer here. All right, and we continue to get a little bit more complicated as we go. So I will first deal with this part right here. I'm going to take 8 and square it. So 8 squared is 16. G to the 3 times 2. I see only one base, so I multiply the exponent. So 3 times 2 is 6. 8 to the 4 times 2, which is 8. And then I have all of that still raised to the second power. Okay? On the right-hand side, I'm going to take 2 to the 4th power, which is 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. G to the 1 times 4, which is 4. H to the 5 times 4, which is 20. So now I'm here. PEMDAS tells you that you have to deal with exponents first. So that means I need to move over here now. And I need to deal with this since I still have that exponent up there. Okay, so I am going to take 16 and square it. And when I take 16 and square it, I get 256. And then g to the 6 times 2, which is 12. And h to the 8 times 2, which is 16. Okay? And then I still have that quantity times the 16, g to the 4th, h to the 20th. Okay, and now I am multiplying these. So now I want to take 256 times 16. And when I take 256 times 16, I get 4,096. And then now you see you have two bases. I have a g to the 12th and a g to the 4th. So that's like saying g to the 12th times g to the 4th, not raised to a power. Now what I want to do is I want to add those exponents. So I want to make that be g to the 12 plus 4, which is g to the 16th. Okay, and then I want to take h to the 16th and 8 times h to the 20th. And again, I have two bases, which means I will add the exponents. So I will have h to the 16 plus 20, which is 36. Okay, and that's how that one should look. All right, we're getting there, you guys. Okay, first of all, I have to deal with exponents. So I need to deal with this quantity first, okay? Notice it has a negative exponent on it, so it needs to go into the basement. That whole quantity has to go to the basement. So I have 6x. This is the only one that becomes positive, though, when you move it to the basement, is the outside exponent. So I have 6x to the negative 5th, y to the negative 1, now raised to the third power, okay? This quantity is not going to get touched. There are no negative exponents, so I'm not going to worry about it. Okay, on the top there is nothing I can do. On the bottom, I need to take 6 to the third power, which means that it's 6 times 6 times 6. So 6 to the third power is 216. X to the negative 5 times 3, because I only see one exponent in the bottom and I'm raising it to a power, so I will multiply. Negative 5 times 3 is negative 15. And then y to the negative 1 times 3, which is y to the negative 3. All right, we're getting there, you guys. Now, I still have negative exponents. Okay? So, this is a negative exponent, which means it needs to go upstairs and become positive. This is a negative exponent, which means it needs to go upstairs and become positive. So on the top, I have 2x squared, y to the 5th, x to the 15th, y to the 3rd. This 216 that's on the bottom needs to stay there because it is not a negative exponent. Okay, we're getting there. Okay, now you can see that you have more than one x on the top, so you're really multiplying x squared times x to the 15th. Two bases, so you add the exponents. Okay, this 2 that's right here will stay, but I have x to the 2 plus 15, which is x to the 17th, and y to the 5 plus 3, which would be y to the 8th. And then I have this over 216. And then the very last thing you can do is you can think of 2 over 216 as a fraction and reduce it. So 2 over 216 would reduce to 1 over 108. So this really becomes x to the 17th, y to the 8th over 108. Technically there's a little 1 right there. When you reduce 2 over 216 you have 1 over 108, but you don't need to write that 1 right there. You don't need it. Okay? All right, we're almost there. Okay, I do want to deal with exponents first. So I do need to deal with this quantity first. So on the top, I have this 2x to the 10th. Then I have negative 2, which I will square. Negative 2 times negative 2 becomes 4. And then x to the 4 times 2 becomes x to the 8th. And then y to the 6 times 2 becomes y to the 12th. On the bottom, this is what I have. I haven't touched anything yet. Okay. Now, on the top, I'm going to simplify that a little bit. And I want to multiply, first of all, the 2 times the 4 to become 8. And then here with my x's, I will add my exponents on x to the 10th times x to the 8th. I've got two different bases and I'm multiplying those. So that becomes x to the 18th and then y to the 12th. Okay. On the bottom, I can't add anything together, so I will just leave it for right now. However, I do have negative exponents in here. And so this exponent needs to go up top, and this exponent needs to go up top. Okay? And you will figure out shortcut for these as you go. But on the top now I have 8, x to the 18th, y to the 12th, and then I'm moving that x to the 3rd up and the y to the squared up. This 4 can stay. I'm almost there. Okay, now I'm going to reduce 8 over 4. I will think of that as a fraction, as 8 over 4. And 8 over 4 we know reduces to 2. Then I need to think about adding my exponents on x to the 18th and x to the 3rd. So that becomes x to the 21st. And then y to the 12th and y squared, which becomes y to the 14th. And that is that. All right, now we've got a fraction raised to a power. Okay, we did one a little less complicated than this in the previous lesson, but this one's a little more complicated. When you have a fraction raised to a power, just think about taking the numerator and the denominator separately. I need to put this negative with either the top or the bottom. It doesn't really matter. I'm going to go ahead and put it with the top just to clean it, make it clean. Okay, so on the top then, I have negative 2, x to the negative 3rd, y squared, raised to the negative 2 power. On the bottom, I have 3z raised to the negative 2 power. Again, when you have a fraction raised to the negative 2 power, think about taking the numerator to that power and the denominator to that power separately. Okay? Now, looking at your outside exponents, notice this is a negative outside exponent. So this whole quantity needs to go down so that this negative exponent can become positive. Okay? Likely, same kind of way, this whole quantity needs to go up so that this outside exponent can become positive. The only exponents that are going to become positive are the outside ones when you move it. That's it. That's the only thing that changes. Nothing else changes the signs. Okay? So now I have 3z to the positive 2. And I have negative 2x to the negative 3y squared to the positive 2. Notice that nothing else became positive. Okay? So now in the numerator, 3z squared, 3 squared right here is 9, and z squared is z squared. In the bottom, negative 2 squared is negative 2 times negative 2, which is 4. X to the negative 3 times 2 is x to the negative 6th. And y to the 2 times 2 becomes y to the 4th. Okay, now if you notice, you do have a negative exponent right here, and that does need to go upstairs so that it can become positive. So on the top now, I will have 9 x to the 6th z squared. You do want to try to list your exponents in alphabetical order, or your bases in alphabetical order. On the bottom, I have the 4. The y to the 4th does not need to be moved because it's a positive exponent. So that's what that one should look like. All right, then. This is something that you may see in your homework, just so you know. So I want to just kind of talk about it for you. You need to find the area of this rectangle right here, just so you don't forget. Rectangles have the area length times width. Squares have the formula s squared, and circles have the formula pi r squared. So in this case, in order to find the area of this rectangle, I have to take 5f to the 4th g to the 3rd times 3f g squared. Okay, so to do that, I would just take 5 times 3, which is 15, f to the 4 plus this 1 that's right here, so f to the 5th, and then g to the 3 plus 2, which is 5. And that's all you would need. Technically, you should label that with units squared. I didn't do that. Okay. Volume formula. The volume for a cube is each side cubed, which is this. The rectangular prism is a times b times c, cylinder pi r squared times h. So this is a cube since all 3 sides have the same length. So I would take 4k to the 3rd cubed. I'm using this formula right here. A is 4k to the 3rd. Okay, what that really means is 4 to the 3rd and k to the 3 times 3. So 4 to the 3rd is 64, and then k to the 9th power. And I'm just going to write units squared. I don't know what units they are in this case. It didn't give it to me. Not units squared, cubed for volume, sorry. All right, and that should do it.